Hello everyone. In this video we will be discussing about dynamic memory allocation in C language. Okay, what is dynamic memory allocation? Dynamic in the sense runtime, during the execution time. During the execution time we are going to provide some memory. Okay, so where this concept is related? This concept is related to arrays. Okay, there is some drawback when we are creating an array that I have to discuss. After that I will come to that. Okay, so let me start with a code. For example, I have created an array with size 100 or 1000. Okay, so what does it mean actually? 100 integer numbers, am I right or not? If you are creating an array with size 100, it means you have created how many? 100 integer numbers. And you know that each integer variable occupies how many bytes of memory? 4 bytes of memory. Each integer variable occupies 4 bytes of memory, and you have created an array with size 100. Totally how many bytes of memory you have created? 400 bytes of memory you have created, where you can store 100 integer numbers, right? For example, I have created an array with size 100 in I comma I, and I am writing my for loop for I equals to 0, I less than 5, I plus plus, sorry, I equals to 0, I less than 5, I plus plus. And you are trying to store how many values? For loop you have written up to where? 5. How many values you are going to store there? You are going to store only how many values? 5 values. You have created an array with size 100, but you are storing only 5 values. Your 100 elements can be stored there, just like 100 chairs are arranged, but you are just allocating how many members can sit there? Just 5 members are sitting in this room, one particular room. There is a room with 100 chairs, but only 5 members are using. Remaining 95 chairs are wasting. Means each chair here, each slot is 4 bytes. 95 into 4. Totally 380 bytes of memory we are wasting. We can see in another way also. If you take even n, they are asking, like we'll write a step like printf enter n. Okay, after that scanf percentage d ampersand n. Okay, so here we will be writing I less than n, and this loop will be running how many times? N number of times. Let us assume this program we are executing for 100 times also, 200 times also, but n value always we are giving only 5, 6, 7, 8, 9. You have created an array with size 100, where you can store 100 elements, but always you are going to store only 5 to 6 elements. For always storing 5 to 6 elements, you have created 100 bytes of memory. For example, I have created 10,000 by 10,000. Array size is 10,000. Means 10,000 integer numbers you have created. 10,000 integer numbers we have created. 10,000 into 4 bytes. 40,000 bytes you have created, and let us assume that always you are giving n value as 5. Means where you are going to store only 5 elements. For storing 5 elements, how much memory is needed? 5 into 4, 20 bytes. For storing 5 elements, 5 integer numbers, how much memory is needed for us? Only 5 into 4 bytes. Total 20 bytes. Total how much? 20 bytes of memory is enough. But we have created how much memory? 40,000 bytes of memory we have created, which is always we are wasting the size. And another way I will explain. One is memory wastage. If you are creating array size like this, if you are giving array size 10, but you are giving n value as 100. If you give n value as 100, can you store 100 elements In the array size 10, just let me give you an example. There are only 10 chains, like 10 slots are there. But you are trying to accommodate 100 members. Is it possible? No, here insufficient memory. Means whenever we create an array with like this, we call it as, what we call it as, static memory allocation. Means earlier only we are giving the array size. This is going to create two problems. The first problem is always there may be a chances of wastage of memory, or there may be a chances of insufficient memory. Either this or that. Memory, if you are giving more memory here, more size here, it means we are wasting our slots. If your n value is only 10, 20 like that. If you are giving the array size as 10 or something like, we are giving n value 20, then this array cannot accommodate 20 elements. Insufficient memory. So, instead of creating memory here itself, let us create this memory during the runtime. That is what we call it as dynamic memory allocation. What is that? Dynamic memory allocation. Allocating the memory during the execution of a program. I repeat, allocating the memory during the execution of a program is known as dynamic memory allocation. So, in dynamic memory allocation, there are four functions we are using: Malloc, calloc, realloc. These are for allocating or creating the memory during the runtime of a program. And there is a special function called free, which after usage of memory what you have created, that memory also can be saved by using the function called free. I'll show you what is this. Very first, let me start with malloc function. Okay. So let me go ahead. Okay. The very first thing you need to remember is don't create any array, but instead create one pointer. I'm going to write the same program. Don't worry. I'm going to use it as array only. But the question is, very first thing is, don't create just like this 100 like this. Don't give any memory. Just let it be the pointer. For this pointer, I am going to allocate the memory. Look at the step number 7. A equals to the function what I am using for memory allocation is malloc. Okay, malloc. Within that you have to write size of int. What is the size of integer? 4 into n. For example, n value you are giving 5 means size of int how much? 4 into 5. Totally how many bytes of memory going to be allotted? 5 bytes. As you have given the n value 5 only, obviously you are going to store 5 elements only. For example, if you are giving the n value as 100, 4 into 100, 400 bytes of memory will be allocated and you will be storing 100 elements. Means as per n number what you are giving, that much memory only going to be allocated to this pointer. And the best thing, the amazing thing is, after 7th step, the pointer what you have created here, after the 7th step will be acting as an array like this. And look at here, I am going to print the elements also. Printf elements are going to write this again. And here let me write down printf. Okay, ampersand. So let me execute this. N value, now I am giving 5. Can you guess? I have given n value as 5 here, but you know that we have created a pointer. After giving the n value, this memory 5 into size of int 4, 5 into 4, 20 bytes of memory is given to be array, and from here onwards it will be acting as array with size 5. Now look at, I can enter 5 elements, 1, 2, 3, 4, 5. I have entered 5 elements, and see here, whatever the elements I have entered, I am printing. This is just array program. Whatever the array topic you have learnt here, the same all the arrays concepts can be, all arrays programs can be applied here. But In this step, don't declare it as like this. Instead, you create one pointer and use this step. The only modification is this step. And instead of this array, you are going to create pointer. That's it. After seventh step, you can use any array program, whatever the array program you have learned. Now look at, I want to calculate the sum of elements in an array. What is the logic for sum of elements in an array? X equals to x plus a of I. After this for loop, I am going to printf percentage d comma where the result is stored x. And here let me change weights and let me write down, and initial value of x I have to give that x equals to 0. And just check out, this is just the logic of sum of array elements. Okay, but in the fourth step I have not created any array. But from after seventh step, I am going to convert this pointer into an array dynamically. After executing like this, I think I have given one more. After executing like this, okay, n value 10 I am giving. It means that that particular pointer what we have created, for that I have given size 10, means it will be converting as array with size 10. Now I am allowed to enter 10 elements. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And what is the sum of 10 elements? 55. That is the answer. Not this. Let me execute one more time. N value this time I am giving 5. 1, 2, 3, 4, 5. And sum of 5 elements is 15. 1 plus 2 plus 3 plus 4 plus 5. And see here, whatever the n value you are giving, those many elements only you are allowed to enter. If you are giving n value 5, you are allowed to enter 10 elements, 5 elements. If your n value is 100, you are allowed to enter 100 elements. Means memory as per requirement. Memory as per requirement. Okay, and there is one more function called calloc. Instead of m you write down just c. For calloc you just write comma. Here instead of star you remove it and put it comma. And again the same code. Now again it will be acting same. N value 5 I am giving. Now I am allowed to enter 5 values. 1, 2, 3, 4, 5. Now again we got sum of elements as 50. And the first one what I have explained is Malloc for allocating the memory during the runtime of a program. This is the syntax or model for allocating the memory here in Malloc and into n. But for calloc remove into, just put comma and write down C. And the same logic, entire the same memory will be allocated. Then you may ask me what is the difference between them. C can call it as contiguous memory allocation. For with Malloc, what happens? No, all values, all array values will not be initialized with what? 0. But in calloc, all array values will be initialized with 0. That's it. But internally this won't affect anything. Okay. So this is how the Malloc calloc works. And Malloc calloc is done. Okay, right? I have done. I can write any program. Bubble sort program also you can write. The entire logic of bubble sort you can write here. Just only thing is in the bubble sort program you just don't write array of 10 like this. Instead, you create one pointer and use Malloc or calloc. Malloc or calloc. Okay. So now the question is, now let me show you one PPT here. PPT functions are there for dynamic memory allocation. Malloc is there. You have shown you. Calloc is there. I have shown you. What is realloc? This is interesting. For example, you have given some memory here. You have entered the elements. You have calculated the sum of elements. You have printed it. After some time, if you feel like you need more memory, you want to give more memory to that, just write down a equals to realloc. Okay, realloc, what is the old value you have given? Okay, just ignore that. Where you have given the pointer a. Okay, now write down size of Again you write down int into how much memory you wanted to give. Let me create one more variable for creating the new memory, comma m. Okay. So now here you observe printf enter new size. Okay, new memory. Earlier you have given n elements, n. Now you are giving m. Okay, percentage d comma ampersand m. Now new memory will be allocated into m, semicolon. And again the same thing. Again I am going to write the same code. Again look at here. But this time the for loop limit is not n. This time the for loop limit is m. Okay. So now here let me write down x equals 0. Why I have written, I'll tell you. Sorry, here we have to write into, as malloc we are using. Now look at here, enter n. Now I have given the n value as 5. Now I am allowed to enter how many values? 1, 2, 3, 4, 5. 15 is the answer. Now I feel like that 5 is not sufficient for me. I want to give new size. Now I will give the size 10. For the same pointer A, I am giving the size 10. Now memory gets increased. Now I am allowed to enter how many values? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I have entered 10 values and I am going to print the sum of 10 elements. Look at. So what I have done? Malloc calloc is for allowed to get the memory. Okay, like this. Up to here. Up to here the code is malloc calloc. And after that, if I feel like I have to give some new memory, I am using the m, and this is the logic step for reallocating the memory. Realloc, just give the pointer, old pointer, where you have given the old memory, and size of int into m. This time you write down size of into m. And the good thing is I can save this memory also in computer. Just write down free of n, whatever the memory you have given, free of a, that's it. You just give free of a, where you have given the memory, that memory will be released. Now you need 5 elements, n value 5. Now you are using entering 5 elements and you are getting some result related to 5 elements. This is sum of 5 elements. Now you have given the new size. New size is 8. Now 1, 2, 3, 4, 5, 6, 7, 8 value. 8 values given and sum of 8 values you are getting the result. After getting result printed, whatever the memory you have given to A, all that memory will be freed, means erased. That the memory you have utilized for this program also can be saved from our computer. These are the most important methods you need to remember for dynamic memory allocation. What are those? Malloc, calloc, realloc, free. Malloc is for memory allocation. Calloc is also for memory allocation. Reallocate is for already if you have allocated some memory by using malloc, calloc, you can enhance that memory by using realloc. And the memory what you have created can be deleted also by using the function called free. Okay. So here again before closing this session, just do remember how malloc works. Malloc, size of int into n. If it is calloc, just you put comma. Calloc. That's it. Over. Okay. And this is how we need to use realloc. Realloc step is this. 93. You just concentrate on this. The remaining code is related to arrays only. Okay. Now you can use free function also. This is about dynamic memory allocation. In this way you can save your array memory. Instead of wasting, instead of not insufficiency problem, we can avoid that by using just creating a pointer, and later on we can allocate the memory as per our requirement at that time. Okay guys, hope you understood what dynamic memory allocation is. Thank you.